Welcome to this explainer on mastering AWS IAM policies and permissions logic. Okay, we've got a lot of critical ground to cover today, so let's jump right in. Picture this scenario. You deploy a Lambda function that is simply supposed to read profile pictures from an Amazon S3 bucket. At first, the code works perfectly, but a week later, a completely unexpected bug in that exact same function accidentally executes a delete command and permanently wipes your entire production DynamoDB table. We're talking total failure, massive downtime, and a whole lot of lost money. So you have to ask yourself, how is that even physically possible? Well, it happens because you gave your code the wrong rules, simply because of a lack of understanding regarding how AWS actually decides what your app can access. Let me show you how to actually lock down your applications. You see, when your code runs on AWS, it assumes an identity, like an IAM role. But AWS doesn't really care who your app is. Authentication just proves identity. Authorization decides what that identity is actually allowed to do. And in AWS, authorization is completely governed by explicit JSON policy documents. These policies are simply AWS permission rules attached to your identities, or your resources, that explicitly state exactly what actions are allowed or denied. If you don't write the rule, AWS simply blocks the action. Think about it like a VIP pass at a massive music festival. Your physical IAM role is the badge around your neck. It gets you through the front gate. But when you try to walk into the backstage area, the security guard doesn't just look at your face. They look at the back of your badge to read the strict list of rules that dictate your backstage access. If the rule says main stage only, you get rejected. AWS evaluates API requests the exact same way. Section 1. The building blocks: effect, action, and resource. Let's break down exactly how these rules are built. Every statement inside an IAM policy requires 3 specific building blocks. First, the effect. Is it an allow or a deny? Next, the action. This is the specific API call your code is trying to make. And finally, the resource. This is the exact target AWS entity identified by its Amazon resource name, or RN. To implement this correctly as an AWS developer, you've got to practice the principle of least privilege. If your app needs to read profile pictures, your policy should look exactly like this. Effect, allow. Action, S3 get object. Resource, the specific ARN of your images bucket, followed by a slash and a star to include the files inside it. Notice how you don't just grant full S3 access. You grant exactly one action on one specific bucket. Section 2. AWS Policy Evaluation Logic, the default state. So how does AWS evaluate these rules when your app is making thousands of API requests a second? Well, every single request across the account starts with an implicit deny by default. It's instantly blocked. But what if you have multiple policies in play? Imagine a frustrated developer trying to fix a bug who just attaches an administrator policy to the Lambda function, granting it full access to everything. But there is also a secondary policy attached that strictly denies DynamoDB access. What happens then? This brings us to the ultimate golden rule of AWS security. An explicit deny always overrides an explicit allow. Always. Think about that. You can write a policy to act as an absolute blast shield. You can create a rule that says, effect deny, action, DynamoDB delete table, resource star. You attach that to your function. Now, even if someone accidentally attaches a full admin access policy to that exact same role, the AWS evaluation engine will see that explicit deny, immediately stop evaluating, and block the request entirely. The database survives. Section 3. The exam trap. Identity versus resource policies. Now, pay close attention, because this is where people mess up. A lot of developers only ever think about identity-based policies. That's the backpack of rules your Lambda function carries around with it. But AWS also heavily utilizes resource-based policies. Instead of attaching the rule to the Lambda function, you attach the rules directly to the Amazon S3 bucket itself. Now imagine this nightmare production scenario. You write a flawless identity-based policy, giving your Lambda function perfectly formatted permission to write data to an S3 bucket. You test it, and it fails. You get a 403 access denied error. You stare at your JSON code, and the allow rule is flawlessly written. So why did it fail? Because the developer who built the S3 bucket attached a resource-based policy directly on that bucket that explicitly denies all write access. This is a massive trap on the DVA-C02 developer exam and obviously a disaster in the real world.
When an identity tries to access a resource in the same AWS account, AWS evaluates both the identity policy and the resource policy. If either one has an explicit deny, it's a catastrophic failure. The request fails. If neither has an explicit allow, the request also fails due to the default implicit deny. You have to understand both sides of the equation to debug authorization failures.
Okay, let's lock this down. 3 rapid takeaways. 1. Policies are JSON permission rules built on 3 core components: effect, action, and resource. 2. AWS evaluates requests using a strict logic where the default is an implicit deny, and an explicit deny will permanently override any explicit allow. 3. Applications are governed by both identity-based policies attached to the compute role and resource-based policies attached directly to target services like S3 or Lambda. I'll leave you with one final stark warning. Never use the wildcard star for your actions or resources just to make a permissions error go away. You aren't just fixing a bug. You're handing the keys to your entire AWS account to a piece of code that could accidentally destroy your business. So, looking at your own AWS environment today, how many wildcards are hiding in your policies right now, just waiting to be exploited?